78 minimum time to make rope colorful. Let's go ahead and get right into the problem. So Alice has n balloons arranged on a rope. You're given a 0 index string colors where colors I is the color of the ith balloon. Alice wants the rope to be colorful. She does not want 2 consecutive balloons to be of the same color. So she asks Bob for help. Bob can remove some balloons to the rope to make it colorful. You're given a 0 indexed integer array needed time or needed time i's. The time is seconds it's going to take to remove the ith balloon from the rope. Return the minimum time Bob needs to make the rope colorful. Okay, so basically you have a series of balloons. Every balloon has to be a different color from the balloon to its left and the balloon to its right, right? So if you have 2 balloons in a row that are the same color, you're gonna have to remove one of them. And that's the example here, right? You blue, red, blue, blue, green. You're gonna have to delete one of these balloons to make it work. This is already unique. And in this example, you're gonna have to delete one of these two balloons and one of these 2 balloons to make it unique. And notice that these things happen at different times. You can only delete one balloon at a time, right? So you delete one balloon here, that takes 1 second. You delete one balloon here, that takes 1 second, a total of 2 seconds. So what you'll notice in this problem, I guess the distinction you have to make, which I think is relatively obvious, right, is that you're basically, whenever you have a bundle of balloons that are together, greater than 1, right? If you have greater than 1 balloon together that needs to be deleted, you're going to have to delete n minus 1 of them, right? If there's n balloons of the same color together, you're going to have to delete n minus 1 of them to make it unique, right? So in this example, you have 2 problems where you have, you know, two color balloons, and there's 2 sets, there's 2 bundles, right? There's 1 bundle to the left of 2 balloons, 1 bundle to the right of 2 balloons. You want to delete 1 from this series and delete 1 from this series in order to make them unique, right? So if you have 2 together, you're gonna have to delete 1, right? If you had, let's say you had 3 blue balloons, and then a red balloon, and then a yellow balloon, for example, and this one was size 3, this one took 3 seconds, this one took 1 second, 4 seconds, 1 second, 2 seconds, 2 seconds, you know, you're gonna have to delete 2 of these 3 balloons. And which 2 are you gonna delete? Well, the ones that take the least amount of time, right? So you'll delete this balloon, and then you'll delete this balloon, right? But whatever it is, if it's more than 1, you're gonna have to scale it down to 1. So I guess the easiest way to solve this problem would be to look at the balloons that you have, like A, B, A, and the needed time associated with them, right? And to delete this balloon, it's gonna take 1 second. Delete this balloon is gonna take 2 seconds. Delete this balloon, 3 seconds, 2, 4. So you can go through and say, well, let's imagine that we have to, I guess the easiest way to do this would be to look at each balloon and say, let's look at all the balloons, and if we find a new colored balloon, we'll look at the previous balloons and say, well, let's eliminate the maximum one that we deleted. So what I'm basically saying is, to delete this, it'll take 1 second. To delete this, it'll take 2 seconds. And then when we get to here and we look at B, we can say, well, what's the maximum balloon of the previous color that we saw? Because that we can undo, right? So the maximum we saw was 2, so we'll remove that from the situation, take 1, 3. So for each bundle of balloons, including the balloon of bundle size 1, we'll always delete the maximum balloon from that set that we've seen so far. So when we see this, we can keep track of the maximum balloon that we've seen and the total sum, the total of deleting. And if we look at that information, right, so for, I kept the wrong information here, so it's 1, 1, 2, 3, 4, 1, right? The max for this is 1. The total is 1 if we wanted to delete both balloons. Now the max of this is 2, and the total is 3 because I'm adding 1 plus 2. And then once I get here, well, for the previous 2, there was 2 of the same balloon. So that means I only need to delete 1. So I can remove the maximum thing that I deleted. So my total would minus 2, because 2 was my max. I'd restart my max at 3. Total would be 1 plus 3, which is 4. And then I look at the next thing and I say, okay, well, my max was 3 for this balloon B. The bundle size 1, so I don't need to delete anything. So I subtract out that 3. I get back to 1. Now my max is the value of A, which is 4. So I add that in and get 5. Then I look at the next balloon. The max is still 4 from this previous balloon. And then I add in the value of this balloon to make it 6. But at the end, I don't actually need to delete. Since there's 2 balloons, I only actually delete 1. So I subtract 1 from that. And then I delete the maximum, which is 4, to get 2, right? Because basically you look at each bundle. If the size of the bundle is 1, you don't have to delete anything. If the size of the bundle is greater than 1, you have to delete. If the size of the bundle is n and n is greater than 1, you have to delete n minus 1 balloons. So you'll delete the n minus 1 smallest balloons. In order to always ensure you delete the n minus 1 smallest balloons, you just keep track of the largest balloon. Okay, so we'll have a current color, and this will just be a dummy value so far. The max current time, and the, what's the last variable we're going to need? And the total time, okay? The current color, we'll just say -1 because we'll update that with a letter. The max current time is 0, and the total time is 0, okay? And then we'll look at each color and each time, and we'll zip together, so we'll look at each color time pair. And then we'll say, well, if the color we're looking at right now is not the current color, that means that whatever the total number of current colors we've seen before, we want to delete adding in the maximum, right? Because we don't need to add the maximum. If it's a size 1, then we just say, okay, before this, right? So we add 1, we add 2. This current color will be the same. The current color will be the same. The current color is not the same. So that means you don't have to delete the maximum that you've seen of these 2 balloons. And then you look at here, okay, the current color doesn't equal the previous current color. So you don't have to delete the maximum of this bundle, which is just 1. So that's basically just saying, okay, you don't need to delete anything because it's only a bundle of size 1. So if that's the case, then you don't have to delete the maximum. So you minus equal the max current time that you found from total time. And now your current color is now the color that you're looking at. The current color is now the current color that you're looking at. And then you'd say the max current time, it resets too, right? Because it's the max current time for the bundle, right? So even if the max current time for the previous bundle of balloons was 12, if the new one's 1, then your max current time for this new bundle is 1, right? Which is the time itself. And then you just say, okay, total time plus equal the time it takes to pop this balloon. And then the max current time will be updated with the max of the current max current time. Max current time, not max current color. And the current time that you're looking at. And at the end, you just return how much time it takes minus the max current time, because that'll be the one that you can delete from the last bundle. All right, let's submit that. So the observation you have to make in this problem is when you have a bundle of balloons, you're going to have to delete all of them except for one. So to optimally delete all of them except for one of them, delete all of them except the maximum one, right? Because the maximum one would contribute the most time. So just delete all of them except for the max one, and you can just keep track of the maximum one in that system. So in terms of space and time, so we'll say n is the length of colors, which is the length of needed time, right? It's just the length of these arrays. It's the number of balloons. N is going to be the number of balloons, right? For time, we just have to look at each balloon, and then we do constant operation, right? This is a constant operation, operation. So this is big O of n. And then for space, we just have to, we make these 3 constant variables. We look at each element, and we update constant variables, so it's constant space. Right? It doesn't grow with the number of balloons that we have. And yep, that's it. All right, guys. Thank you. Have a good